In this video, we'll start a new topic called analytical geometry. Before proceeding into some numerical problems, we'll first understand some of the standard formulas or standard formulae. The first one, distance of the points A, x1, y1 and B, x2, y2 is AB is equal to square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Let us consider this as our y-axis, this as our x-axis. We made a graph. Let us consider this point as our point A, this point as our point B. Point A is x1, y1, and point B is x2, y2. This is our origin, which is 0, 0. So let us consider this particular point as P, this as Q, this as R. I think we kept everything. Now we may notice this OP, we may notice it will be, so we can say OP is nothing but x1. OP is x1. Then let us consider, I made this as Q. Our OQ is our x2 because from here to here, this is what is x2. x2, y2 means this should be yx2. So which means our PQ will be x2 minus x1. Right. Now, this distance, that is AP, will be your y1 because here the point A has got x1, y1. That means this distance should be y1. And then this BQ should be your y2. Right. We are interested in finding the distance between this x1, y1 to x2, y2, which means we are interested in finding the distance of AB. This, you may notice, this is a right-angled triangle. So we can use Pythagoras theorem to find out, to write AB the square is equal to BR the square plus AR the square. Now, BR is nothing but, we can say BQ minus BR, BR square. BQ minus RQ is our BR, the whole square. AR square, AR square can be replaced with the PQ the square. So plus PQ the square. Now BQ, we already know it is y2. Here it is. BQ is y2. RQ, now let us come to that. Here we already wrote the distance as y2. So that means from this we can say AP is the same as RQ. So that means our RQ is already known to be y1. We can say y1 the square. Now PQ is nothing but, we want this distance PQ, that is nothing but OQ minus OP, the whole square. So that means our AB square is y2 minus y1 the square plus, what is OQ? Q, it is actually point is x2, which means this distance OQ is x2. OP is already known to be x1. So this distance is x2. This is y1, which means this is also y1. This whole distance is y2. So this is x1 because OP is x1, the whole square. This also can be written because there is a square. Y2 minus y1 the whole square is same as y1 minus y2 the whole square. Similarly, x2 minus x1 the whole square can be written as x1 minus x2 the whole square because there is a square. Either this way or that way, it will give you the same result. That means we can say AB is square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. So that is what is written here. The distance between the points A1, AX1, Y1 and BX2, Y2 is AB is equal to root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now let us move on to the next one. Distance of the point P x1, y1 from the origin O00 is OP is equal to square root of x1 square minus y1 square. It is simple. We will use the previous one. If I consider PO or OP, it is nothing but root of x1 minus 0 the square plus y1 minus 0 the square. That will of course give us this x1 square plus y1 square. So that is what is the second formula is all about. Now let us move on to the third one. 3 points are collinear. Collinear means it should lie on a straight line. So let us draw one straight line. Consider this point as A, this as B. Somewhere in between, let us have one more point C. Now what it says, the sum of the two distances is equal to the distance of the third distance. Means we may notice AC plus CB is the same as AB. So based on that only this particular thing is, if 3 points, not pairs, or collinear, if the sum of two distances is equal to the third distance. That is very obvious from here. Next, a triangle ABC is an equilateral triangle if AB is equal to BC is equal to CA. Let us draw one triangle, equilateral triangle. Let us consider this as A, B, this point, vertex as A, B, and C. So this is equilateral triangle means all the sides should be same, equal. So here, of course, AB is equal to BC is equal to CA. On that basis only, you can say a triangle ABC is an equilateral triangle if the distances are the same. Let us move on. Isosceles triangle. And if a triangle ABC is an isosceles triangle, if two of its sides are equal. Let us draw one isosceles triangle. Let us consider this as A, this as B, and this as C. So we may notice AC is the same as BC, but AB is different. Two sides are equal. That is what it says. So this is a different side. A right angle triangle, a triangle ABC is a right angle triangle if the sum of the squares of two sides is equal to the square of the third side. Let us draw one right angled triangle. Now let us consider this point as A, this as B, and this as C. So of course, BC is the hypotenuse. So we know hypotenuse square is the sum of the squares of the other two sides. So here BC square is equal to AB square plus AC square. So that is what is specified. If it is a right angle triangle, here the right angle is here. if the sum of the squares of two sides, is equal to the square of the third side. So that square of the third side is your hypotenuse basically. Next, a quadrilateral ABCD is a parallelogram if AB is equal to CD and BC equal to DA. Let us draw one parallelogram. So let us consider this as A, this as B, this as C, this as D. We know in parallelogram opposite sides are equal. So this and this are same. This and this are same. That means AB is equal to CD and BC is equal to DA. So on that basis only this particular statement is declared. Next one, a right angle, sorry, a quadrilateral ABCD is a rectangle if AB is equal to CD equal to BC equal to DA and AC equal to BD. Let us draw one rectangle. Let us consider this vertex as B, A, B, C and D. We know very clearly here AB is the same as CD. And also BC is same as DA. We also know the diagonals are also equal. So even this one is the same as this one. So AC is the same as BD. So that is what here it says. A quadrilateral ABCD is a square if AB equal to BC equal to CD equal to DA. Means we know square will have all sides equal and also the diagonals are equal. So here we'll draw one square. Consider this as to be square. So of course, all these sides should be equal. This should be the same as this. This should be the same as this. Diagonals also should be equal. So here we have AB is the same as BC and BC is same as CD and CD is same as DA and AC is the same as BD. Diagonals. This is also diagonals. Let us move on to the next one. What it says, the quadrilateral ABCD is a rhombus if AB is equal to BC equal to CD equal to DA, but diagonals are not same. Let us draw one rhombus. Here, let's say this is A, this is B, this is C, and this is D. So AB is the same as BC, and it is the same as CD, the same as AD. But AC and BD are not same. So this is different. This is different. So here AB is the same as BC, is the same as CD, and that is the same as DA, but AC is not equal. I mean, I should put 3 lines. Is not equal to BD. So then it is a rhombus.